Hello everyone, today let's focus on the lesson for data models. So, to be able to give a concept overview of what data models are, when creating software, one of the foundational decisions developers need to make is choosing the right data model. It is akin to an architect deciding on the blueprint for a building. The choice deeply influences not only the way the software operates, but also the problem-solving approach. Data models are the lenses through which we view and manage the complex reality represented within our system. So they are the lenses we see for our system. At its core, a data model structure, the way it is stored, accessed, and manipulated. It defines the rules by which data entities relate to each other. For application developers, this means translating the real-world entities into data structures and using APIs to interact with these structures. It's also about finding patterns in the chaos of the real world and fitting them into a logical structure framework within the software. So this is also applying to data structures. The choice of the data model is pivotal because it dictates everything from the performance characteristics to the types of queries and operations that can be efficiently performed. Whether it's a document stored, a relational database, or a graph model, each comes with its own set of capabilities and limitations. As data models layer one on top of each other, from high-level structures in an application down to the bytes on a disk or memory. Each layer for a data model offers a simple interface to structure data. And this layered approach is not just about the technical convenience, it reflects an understanding that different roles involved in building and maintaining a system need to interact with data at different levels of abstraction, meaning that it ensures that application developers, database engineers, and hardware technicians can work efficiently within their domains without needing to grasp the entire stack's intricacies. So this could be a wide variety of different data structures and algorithms that one could be able to apply when actually modeling data depending on the context of our given data that we are using. So even though the data models are considered extensive, they are really efficient when it comes to scalability, and some models are better suited to distribute different forms of data and better suited for different systems. They can influence development speed, such as space and time complexity, and there are more intuitive models which would have better trade-offs when it comes to storing data, or also the efficiency of what data model we would use. So, to provide context, we focus on efficiency for data storage. Let me move over here. Whoop. And access. So to be able to solidify our given concept, let's go over a concept example. So we're going to be focusing on content management system. To illustrate the importance of data models, content management system is a software used to manage digital content. A content management system developer might look at real-world articles, media, and user interactions and choose a data model that best represents these entities and their relationships. So we're ultimately using data models to represent real-world articles, video, and media as digital objects for data. And to go over the entities that are required in particular to be able to build the content management system, it's going to be the following steps. One, we need to figure out the entity representation. Second, the storage and retrieval of the media. The third and fourth are going to be, the third one's going to be focusing on queries and manipulation. And the fourth one is going to be focusing on hardware considerations. So let's go over each of the 4 steps, or 4 parts. So entity representation is going to represent each article image or video to be an object to be stored in a database, where that could be a relational database or document model. So we have a relational model. Model or document model, where they would be stored in various objects. And to be able to go over the differences between relational and document model, let's put this over here. Relational let's move over here. Use a different color. Relational refers to, so relational model refers to data represented by rows and columns. A vivid example would be SQL. And meanwhile, a document model would represent objects stored on a document that could be any data types like strings, integers, or other data types. good example would be JSON or XML. So that's a bit of a side note for us on relational and document. And so then when we go over to storage and retrieval of media, once the objects are created, they need to be stored in a database. So objects must be stored in the database. And we could have a relational model where that would refine where it would involve around their tables and their relationships, while the document model might simply be about storing and indexing documents. And meanwhile, for queries and manipulation, the developer needs to consider how these objects will be accessed. So how will the objects be accessed? They will need to perform complex joins. So we need the relationships defined for them. So we need relationships defined for each object. And this is where a relational database actually excels over a document, because you can discern relationships between the two. And so the hardware considerations would also consider how these data models translate to the hardware level, understanding between what hardware is required. Are we doing, for instance, a document or relational model? And a key point I also need to bring up is that for their applications between relational model and document model, a relational model is great for, just gonna do this, great for structured data. And a document model is great for unstructured data. That's a key relationship between them. And so let me zoom out. There we go. Just need to expand upon this. And so, yes. This would be the case for content management. And to be able to give an overview of our diagram of what we need to consider the full system, how it's going to be operating as a full stack application, and exactly what services that we're also going to be using in terms of front end and back end, just to give an overview, and its distribution as well. But this is just the overview for content management systems. Now let's go over a practice problem to help solidify our concept. So let's be focusing on a social media platform and then focusing on choosing the right data model. And this will just be an outline on how to make the decision for the right data model. In later lectures, we're going to be going over the different types of data models. So in the meantime, we're just going to be going over the overarching scope over what it takes for model selection and assessing specific data models to apply. But right now, we're just going to give an overarching concept overview. So the first step for us to be able to actually figure out what it means to be able to build a social media platform with the right data model, understanding which data structure would we need to use, is to understand the entity relationships. What is the data? Data, and how do we put them in objects for object-oriented program? And the next part is to select the model to be able to match the objects. Let me just erase this. To give an example, we can have a relational versus data model. Next part is going to be implementation. Recognize all faults and potential failures. And also understand the relationship between the database, cache, and queue. So that way we know exactly what it means to communicate and update data in real time. To communicate and update data in real time. Next part is optimization. How do we make it better for speed and efficiency and storage? And storage. So speed, efficiency, and storage. Finally, evaluation. How well does the data model fit with real world implementation object creation, storage, retrieval, and manipulation. So to be able to go over each of the following steps, just give them some extra space, is that within our social media platform, for instance, we already have data points that we need to take into consideration, such as a profile's user, or even actions that we need to consider how that data is going to be interacting with each other. Such as for Instagram, we would know about likes, followers, people to follow, and then posts to also be able to post within a given timeline, and how it will be curated within a different feed. So, for instance, in our given example, in Instagram, we have an action called tagging people. Now, we already know from our previous lecture that there are IDs already associated with every single profile that a person's going to be using. And then that profile is also meshed in with other profiles at the same time. So if a person were to instance, make a post on Instagram, that post is already associated with an ID from one profile, and it's already fanned out to multiple profiles, and it's already organized on the home feed as a series of timestamps. Organized by profile and timestamps like mail delivery. And so once we have already done that, we would then further understand between, okay, so when a person's already making a post or they're tagging a person, they are associating that data model of a post or a profile or a picture or a video, which are different intricacies of data which could be meshed in between one profile to a series of other profiles in the fan-out effect that we talked about in the previous lecture. And so what we need to do overall, just going over the steps, to be able to implement and create a data model is we need to understand the entity relationships. Just clean this up. What is the data? How do we put them into objects for object-oriented programming? And we will first assess the features requirements to understand the relationships between different pieces of content. And does the relationship data have a clear structure, or is it more free form? So, is the data structured or free form? In this example, it's relational model versus document model. And we're going to have a different lecture video come up talking about the differences between relational and document models as well. And in the second step, we need to talk about the model selection and then understanding the requirements. One might offer a graph data model in particular, for example, which is another form of a type of data structure as well, to make connections between different user profiles as well. Use a graph model. And then we figure out the implementation strategy. And remember, every single data system is always going to have a database, cache, and queue. And understand between the failures, the faults, which would eventually become failures, and have independent testing from the human, hardware, and software side to be able to actually implement our data model. Then the next part we would need to consider is optimizing, and we need to consider the volume of the content and frequency of searches. So we need to ask ourselves, about scalability. And then finally, for the fifth step, we need to consider how well is this going to do in real world situations. So we need to ask, how well will the data model adjust in real world situations? And then we need to consider continual adaptation of the data model. And so yes, let me see if we can just fan this out and span it out a little bit more. And I'm also going to have the practice example problems also in the description at the same time. Let me just go over here. Yeah. Now, to cement the concept of data modeling, let's look at our second example of focusing on a practice problem for a multiplayer game. So this is also the reference article at the same time. I'm going to put it in the description below. But to give an understanding of exactly what it takes to be able to apply a data model specifically to a multiplayer game, we need to understand really just a whole scope between the features that it require and are needed within a gaming platform where players can form alliances, compete, and trade virtual items. We need to keep track of these interactions and transactions in real time for a seamless gaming experience. So every single data system is going to require us to have a database, cache and queue, keeping information all set up in real time. And the way that we're going to be able to build and scale our data system is going to be the following. One, we need to understand interactions. Two, choose a model. Choose a data model. The third part being real-time processing. Fourth being scalability. And the fifth part being testing and iteration. So going over these steps necessarily, to understand the interactions, we need to analyze player interactions, and unlike static content, these are dynamic. So we are dealing with dynamic data objects. So we could have a series of integers or counts depending on players' interactions of choice, depending on if they ever want to attack, kick, melee, or for instance, trade a certain item that is based within a list that we could have. So we're going to have multiple data structures within data structures as we are playing users' interactions within the game, since they're going to have different data types such as objects that they're going to interact with, or actions such as chatting between each other, that we would need to integrate different structures altogether. And then for choosing a model specifically for this, we're going to need a combination, as stated before, combination of data models to encompass full game experience. And then in the case of real-time processing, we need to create a data model that supports real-time processing with updates and such as in-memory game storage. Model must support real-time processing, and yes, that also means cache updates. Consistently. And the data model in of itself can also abide by Twitter's own model platform, where they are able to store caches locally, so that way a user's profile can also upload the previous data that was already stored. And in this case, we could see different transactions between different profiles and interactions between players. We can, for instance, apply a graph model to keep track of players properties, which can also refer to actions, inventory, etc. And when it comes to scalability, given the potential of a large number of concurrent players, scalability is going to be a priority. So we're going to need to design the data model to distribute loads across multiple servers. So we're going to have a data model distribute loads across multiple servers around the world. And finally, for testing and interaction, after implementing the models through testing and under real-world simulations. So we are considering all potential faults and failures in isolated testing environments one second. For hardware, software, and human. Paradigms. So all together, we will be able to create our multiplayer online game that is scalable across the world. So let me move this over and show you the full. So over here. So this is our solution for a second practice problem that we would have in the case of our multiplayer online game. We will understand the interactions. Let me just clean this up. Choose the data model. Account for real-time processing, scalability, testing, and interaction. And iteration. And so, yeah. So this was data modeling and choosing data models altogether for this lesson. Thank you again for taking time to watch this. If you found this helpful, please, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.